Okay, in this half of the video, I'm going to show you how to calculate the uncertainty of the speed for the IB moving plots lab. Okay, so let me just show you how to do this. Let's divide this space up here. There we go. Let's draw a little line like that. Oh, I just love to draw those lines. It's so much fun. I can draw them so straight. Okay, so let me just show you this. Okay, here is our time. We think that time it's 3.75, right? Plus or minus 0.2. Okay, we just made this up in class. Your class might have used a different number, but if you're making up this lab or trying to figure it out, let's just use 0.2, right? And that's seconds, that's the time, right? And then our displacement was 30 meters plus or minus 1 meter, okay? And everybody used that, right? Now what you do is the first thing you have to do is you have to actually calculate what the answer is, okay? I did 30 divided by 3.75, right? And I got 8. Then you set up a little proportion here, right? So you go, the uncertainty of velocity is to what the velocity is. Okay, so the velocity is 8, right? That equals the uncertainty of time, so that's going to be 0.2 divided by 3.75 plus the uncertainty of distance divided by the distance, right? So 1 meter divided by 30 meters, right? Now the seconds here and the seconds there cancel out. These are actually pure numbers, right? This is, so what we've done is we've set up an expression that says the fractional uncertainty of, in this case, a quotient, right, is equal to the sum of the fractional uncertainties of the operands, of the things that we divided, right? Okay, so this is the fractional uncertainty of time, 0.2 seconds worth of 3.75 seconds. The fractional uncertainty of displacement is 1/30th, right? 1 part in 30, okay? The rule for uncertainty is that the uncertainty exists in the product or sum in the same proportion as the sum of these guys, right? So now how do you solve for this? This is the uncertainty, not the change in velocity actually, but the uncertainty of velocity, right? Well, the answer is you just multiply both sides by 8. Multiply both sides by that denominator, right? So 8.008 times this just cancels that, right? So now literally take your calculator and go 0.2 parenthesis 0.2 divided by 3.75 plus 1 divided by 30, no other parentheses needed, times 8.00, right? I'm going to do that with my calculator. Left parenthesis 0.2 divided by 3.75 plus 1 divided by 30 times 8. Did I type that? Indeed I did. Now I'm going to hit enter. What a wonderful thing to hit enter. 0.6933, right? 693 bar is what I get for that, right? And that's meters per second of speed, because this had the units of meters per second. So although those are pure numbers, the denominator here was not a pure number. This was meters per second, right? So the uncertainty is 0.6933. I think IB wants us to calculate this at plus or minus, and then they want us to give us 2 decimal places. So I'm going to say 8, and the 8 is plus or minus 0.69. Okay. Notice that we've got hundredths, tenths, hundredths, tenths, hundredths. That works. Okay. Now the only thing that's going to change in all the other calculations, right, is the time and the velocity that you're using. Let me just show you. I do a couple more examples here. You can, of course, hit stop. Right? Okay, so let's do the next one here. 4. Okay, 4 yielded the answer 7.23. So the uncertainty of the velocity is to 7.23, as the uncertainty of time, which is 0.2 over 4.15. Plus, and then of course the distance is always going to be 1/30th, right? Okay. So again, this is the fractional uncertainty. The uncertainty of velocity over velocity would be the fractional uncertainty of velocity, right? Equals the sum of the fractional uncertainty of both time and displacement, right? That's our rule. So of course we multiply both sides by 7.23. And this guy goes the way of the bison, and now we're set, right? So I'm going to go left parenthesis 0.2 divided by 4.15 plus 1 divided by 30, right parenthesis times 7.23. Did I indeed type that? I did type that. I'm going to hit enter. and I get 0.589, 0.5894. Okay, now I'm going to round that to 2 places because I think that's what IB wants. So 0.59. So this guy is plus or minus 0.59, and that's meters per second. Right? Okay, let's do one more. Let's do this guy here, 3.12. Okay, that yielded the answer 9.62. Right? So I go, uncertainty of that velocity is to what the velocity is, 9.62, right? And then that equals 0.2 is always the uncertainty of time, and then what is this, 3.12? Right, so it's always the uncertainty of time over time plus 1 over 30, right? Okay, so let's see. Again, you know, we've got the fractional uncertainty of velocity equals the sum of both the fractional uncertainty of time plus the fractional uncertainty of velocity, right? So now I'm going to do parentheses, multiply both sides by 9.62 to cancel that guy, and then I go, again, I type left parenthesis, 0.2 divided by 3.12 plus 1 divided by 30, right parenthesis, times 9.62. Did I in fact type that? I'm kind of got lighting issues here in the basement. Okay, 9.62. Yes, indeed. Enter. Maybe I'm just getting old. This is 0.9373 bar, somewhat surprisingly. Okay, I would round that to 2 places, so I guess I'd have to say 0.94. This is plus or minus, not this guy, not these guys, right? But this number there is plus or minus that. This number is plus or minus 0.94. Ta-da, meters per second. Oh, I must draw a line now. There we go. I gotta draw a line here too. Very disorderly. Okay, so I want you to show me at least 2 of these. So for 2 of them, I need you to show me this expression. Okay, for at least 2, I need to know that you're changing your time changes, right? And then you're changing this, right? Show me at least 2 of them. Please calculate all of them. Make a column that is uncertainty, right? Uncti in meters per second, right? Calculate that column out right down there, okay? You don't have to show me all of them. If you show me all of them, though, I'll be very impressed. And so will your parents. I think that's all I need to show you.